Okay, this is a lesson about interval notation, set builder notation, just how to write sets of numbers. So this is all about writing sets of numbers right here, ways that we can denote subsets of real numbers. There's a lot of confusion about this bracket and parentheses thing. Um, and I'll show you what you have been taught. Well, not what I taught you, but what other algebra teachers have taught you. So if I want to describe the set of numbers that go from 2 to 9, including 2, not including 9, there's three different ways I can describe that set of numbers. Way number one is interval notation. Way number two is set builder notation. And this is how we read that set builder notation. All x, x big bar means all x such that x is greater than or equal to 2 and less than 9. This is going to be what we call a compound conjunction because it includes both numbers. We talked about that a little bit. So we have interval notation. You notice the bracket and you notice the parentheses. The parentheses mean that x cannot equal 9, but x can indeed equal 2. So if I want to graph those on this number line, we can put just a reference point of 0. We're going to come out here to 2 and over here to 9. And this is how you would graph this set of numbers. I'm going to do it in green here. You would have this bracket and this parentheses and all the numbers between that. What some of you have learned, and there's algebra books that teach that, is this closed circle, open circle. And that's the same thing, but you will never see in any advanced math courses the closed circle or open circle. And that's what we're getting ready to do, some advanced math. That's why we do bracket and parentheses. The bracket refers to closed circle, i.e. we can equal to. The parentheses says open circle, we don't equal 9. So we're less than 9 and greater than or equal to 2. Okay? We are going to, in this particular class, especially next year or in any calculus class, we're going to use interval notation and set builder notation most often. So example number 1, we have denote the subset of the real numbers using the three different ways one method will be giving you, will be given. The first and the method that I'm giving here is the interval notation. That is not a point. That denotes a set. And you, hey, if I'm just writing out here in the world of mathematics and I go, hey, -5, 12, how do I know that that's not a point, or how do I know that that means an interval of numbers? You really don't. You have to read it in context of the statement. So just out in the real world, if somebody just wrote -5, 12, you would think that was the point, and it probably would be. If I wanted to denote an interval of, then I would have to explicitly say that in a particular statement, like this. Interval notation. What does that mean? Here's what it means in set builder notation. And if you can use a brace there, you can, or you can just do a squiggly line. So the set builder notation is going to be all x such that x is greater than -5 and less than 12. Close bracket, or that's not a bracket, close brace. Okay, so let's denote that graphically. We're just going to go to a reference point, have 0 as a reference point, go out here to -5, go out here to estimate at 12. Please do not do dashes because it's just an estimation. And now we want neither one of them to include -5 or 12. So we're just simply going to do, I think I'll do this in red, parentheses, okie dokie. Interval notation, set builder notation, on the graphical notation. Okay, example number 2. I have given you the set builder notation, and I want the interval notation and the graphical representation. So what do I have? I want the x's. This says all x greater than -5 and less than or equal to -15. When we have this compound, that means an and. All x such that x is greater than -5 and less than or equal to 13. So let's go interval notation. The interval notation for this rascal would be parentheses -5, comma, 13 bracket. And if I graph, I go 0 as like, reference point. Go -5, go out here wherever you think you want 13 to be. I'm going to do this in red because it's a pretty red color. I go parentheses, does not include -5, bracket does include 13. And now you should be able to see, for those of you that had me in Algebra 2, I wanted you to start going away from the closed circle, open circle. Miss G likes the closed circle, open circle, mainly because that's how most textbooks in an Algebra or Algebra 2 class give it. But rarely, though, you'll see, like advanced book, say open, closed. So you will see parentheses or a bracket. Okay? Carry on to example 3. Now I have this or statement. This is going to be kind of funky with the set builder notation, but not that bad. Keep in mind, this guy here is an and. This is an and statement. And this guy here is an and statement. And now we're delving into the world of all statements. And before I go set builder notation, I'm going to do a graphical representation. Let's go reference point of 0. And what this says is I want the numbers less than 1. Between -infinity, and you never put a bracket on infinity because infinity is never ending, it never closes. So whenever you have a parentheses in your interval, or whenever you'll have an infinity, either positive or negative, you'll use parentheses with the infinity symbol and not the bracket. So what numbers does that interval represent? The numbers that are less than 1, and they go on forever. And then I'm going to go to 3. I go to reference point. I got the 0. I'm going to go 3 about right here, and I'm going to go out here to 17. And I'm just going to get wild and just really cram those numbers in. And I want to include 3. Boop, 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 boop. And I do not want to include 17. And that is a graphical representation for those sets of numbers. Now that is to set a builder notation. Will you stop talking like that? I can't. You could. You just did. So I want all x less than 1. Or the x's between 3 and 17. So all you simply do is you just put an or statement. And you notice here that I don't have any infinity. I could have put greater than infinity. The best way to write that is just x less than 1. Because x less than 1, and it says that x is greater than -infinity. Okay, that's the best way to write that. All right, I'll let you catch up. I drink all coffee. Now, although this will not be tested or assessed on the unit assessment, you will need to know how to write sets of numbers using interval notation or set builder notation, because we will talk about sets of numbers. We'll talk about domains and ranges with sets of numbers. Okay, So it's important. This is an important mathematical lesson. Next page. Okay, so now we're going to solve an inequality, and we're going to write the solution using all three methods. So this is an OR, and this is a simple inequality to solve in all statements. So we did a lot of these earlier. So we're going to add 9 to both sides. This is going to be 4. Ah! Don't write in yellow. That is not good. Solve one at a time. Add 9. It's back. Add 9. 5 plus 9 is 14. Notice I didn't write that step, if that's all right. Now I'm going to divide by 2. The coefficient of the x is not positive or negative, so it's okay. The sign of the inequality symbol will not change, and I just have 7 is greater than x. And keep in mind, we can use the symmetric property and say, hey, you know what? That says that x is less than 7. Either of those are okay. I like my inequality symbols to open to the right. Okay, so let's do this other guy. And keep in mind, this is an OR. Let's add 4. If we add 4, negative 40 plus 4 is negative 36. Greater than negative 3x. Now I'm going to divide by 3. Negative 36 divided by negative 3 is going to be positive 12. And what happens to the inequality symbol? It flips. So make note of that. And so now I have x is less than 7, or x is greater than 12. So before I write interval notation, or before I write set builder notation, let's graph the solution. No, 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 yes. So let's just do a reference point of 0, because 0 is nice, and let's go out here to a 7, and over here to a 12, close enough. And we want less than 7. So we can do this in green, and we want parentheses. We're not including 12, so we're going to go parentheses. So that is our graphical solution set. So we're going to go to the interval notation, which is going to be parentheses negative infinity, comma 7. Close parentheses, you write the word or, parentheses 12, comma, positive infinity. Close parentheses, and all those are parentheses. That's the interval notation for that set of numbers. I drink coffee. Now I want a set builder notation. I go blue, squiggly line, x, straight bar, all x such that x is less than 7, or x is greater than 12. Good? You good on this? You good? Let's do another example 5. Alrighty, example 5. So, So now we have a compound and. When I put those two inequalities together, automatically this is an and. I'm going to show you the difference between the next two examples, the difference in the ands, and it's just how they make note of it, denote. I can do that all at one time. So what I'm going to do is subtract 13, and I'm going to show the steps this time. Okay, negative 35 minus 13 is negative 48. And I would ask that you help me with the arithmetic, because sometimes I make arithmetic errors. 27 minus 13, I believe that, is that 14? Okay, good deal. So now, I haven't divided or anything, and I'm doing this, both of these inequalities, there's two inequalities there at the same time, subtracting 13. Now I'm going to divide everything I see by 4. Okay, and negative 48 divided by 4 is 12, and it's going to be negative 12. I have not divided by a negative, so the sign remains the same. 4x divided by 4 is x. 14 divided by 4, not a whole number, and we can write that. Can we write that? And we know that that is equal to 7/2. Okay, so that's my solution set. Now I want to do interval notation, set builder notation, and graphical solution to that. And let's do the graphical solution first, just because. Do a reference point of 0. I want negative 12, just come out here to negative 12. 7/2 is going to be equal to 3.5. Let's just put a reference point here. It doesn't matter, 3.5. I got all kind of colors going on here. I'm including 12. I will do the graph in green. I want bracket, I want brace, and the numbers in between. Okay. Interval notation. 1 to interval. Hopefully you can write interval notation. Should I quiz over this? I don't really want to, so I don't think I'm going to. So interval notation is going to be bracket negative 12, comma 3.5. Now, I forgot to mention this. If I were out in the world of mathematics and I wrote this down exactly like this, automatically you should realize that I'm talking about what? An interval, because a point would not use a bracket. So that automatically has to, dude, well, that's an interval. That's an interval. That means set of numbers. That doesn't mean a point. Okay, so set builder notation then. Let's use the pretty blue color. Squiggly line, all x bar, x greater than negative 12, greater than or equal to negative 12, x less than 3.5. Oh, squiggly, because you're closing the parentheses. You're closing the brace for the set. Okay, I think we have one more example here. So this also is an and, but it cannot be written as 1 because I have different expressions in x. So I'm going to solve them. The first one is going to be easy. Subtract 3. I don't need to show the steps. This is just 1. X is greater than 1. Subtract 3. Let's add the 7 here. This is going to be 3x. I don't need to show that step either, I don't think. 18. Divide by 3. I have x is less than 6. Okay, this is kind of an easy one. So now I want interval notation. It's an and statement. I want, notice x is greater than 1 and x is less than 6. It's an and. So I'm going in interval notation, then it's simply going to be comma 1, comma 6. Set builder notation, squiggly line, all x such that x is greater than 1 and x is less than 6. Close squiggly line. To graph this, put a point of reference 0, go to 1, go to 6, use your pretty red, and there you go. Okie dokie.